Hello, this is Jacob Bandic for ME210 Dynamics, video assignment number 3, Energy Methods, and I decided to do a dropped wallet for my video. So here's my picture. Down here I have my coordinate axis. Here's me, I'm holding my wallet. I drop it, so I've included that V0 is 0. And the height that I drop it from is my height, and I called that H. Down here, I know that my height is 5'9", but I figured this would be easier to do in metric units. So using the fact that 1 foot is 0.3048 meters, I have converted my height into metric units, which turns out to be 1.7526 meters. So the information given is my height, 5'9", or 1.7526 meters, and the wallet weight, which I weighed it to be 0.085 kilograms, about 3 ounces, and that actually doesn't end up mattering, which I found kind of interesting. I have assumed that the wallet can be treated as a particle. I've assumed that gravity is negative 9.81 meters per second squared, and that's constant. I have assumed that there's no air resistance, so there's no work done on the wallet by the air. And I've also assumed that V0 is 0 meters per second because I dropped the wallet. We will determine the velocity as it hits the floor and the time to reach the floor. The equations that we will use for this is that potential energy in this case is equal to mgh, and kinetic energy is equal to 1/2 mv squared. And then for the time, we have the final velocity is equal to v0 plus acceleration times time. So here we use the conservation of energy, that the initial potential energy plus the initial kinetic energy is going to equal the final potential energy plus the final kinetic energy. So initially, we have mgh, and since the velocity is 0, it's being dropped, there is no kinetic energy. Similarly, at the end case, the wall is on the ground, so we know that h has gone down to 0, there is no height difference, and there's no potential energy. There is, however, kinetic energy because all of the potential energy from the first case has been transformed into kinetic energy. So here we plug in the known values, the weight of the wallet, gravity, the height, and here we have just the weight of the wallet plugged in. You solve for final velocity, and as mentioned earlier, weight actually doesn't, or mass doesn't matter, it gets canceled out. So in the end, you have final velocity is 5.86 meters per second down, or 13.12 miles per hour, if that resonates better with you. And here to solve for the time that it takes to reach the floor, you use a kinematic equation as shown previously, and solve it for time, plug in the values, and you get that it takes about 0.598 seconds to reach the floor, which seems about right.